children. Today we're going to learn something about assembly and ASCII and ASCII and assembly. It's just been bugging me for a while and I'm trying to learn it. Let's teach you to. So what we're going to do is we're going to discuss a very simple problem. We're going to take two inputs from the user, which is 2 and 3, and we're going to add them and show that the result is 5. That's all we're going to do. On the face of it, it looks very simple, right? We do add 2 and 3, something like this, it will give us 5. The problem is in assembly, that is not the case. I mean, I wish there was, but it's not the case, so we have to do some fiddling. Let's start by creating a model for our code and assume that everyone knows the basic of assembly code. Okay, I'm gonna take the mouse, tap H, and we don't need the data section, so we're just gonna put code section procedure. We're gonna write our exit function here, move H, force H. Okay, so right down here. Now what we need is we need to take 2 inputs, so we're going to take 2 inputs, H1 and 21H. This is our first input. We need to move the input. You see, so when we take an input, it stores the value in AL register, and we need to take another input. So if we take so the AL register is already occupied, so if we take another input, it's just going to overwrite the value and we're going to lose the previous value. So if we're going to put, let's say, 2 here, we need to store it in PL plus AL plus 2. So when we're taking another input, let's say 3, we do not lose the value of 2. See, AL is now 3, not 2, 3. Okay, now we have our AL, we have our PL, we're gonna add them. AL, and now this, what's it supposed to do? It's supposed to do 2 plus 3 equals 5. And if we like print it, H2, DL, PL, it should give us what we want to. Alright, and then Surimi 2 and 3, but it doesn't. You see, as I said, this assembly thing is really painful. So we know that 2 plus 3 equals 5, but the computer thinks 2 plus 3 equals E. How did this happen? Let's see. The ASCII value that is equivalent to 2 is 50, and the ASCII value that is equivalent to 3 is 51. If we add these two, it equals 101. And what is 101? Voila, it's E. So when we're inputting to the computer is thinking, well, it's 50. I mean, the AL register is storing 50, not 2. So the AL register here, it's storing actually 50, not 2. It's gonna store 50, and this one is gonna store 51 and not 3. So what it's doing is doing 50 plus 51, which equals to 101, and so the output becomes E and not 5. So how do we get around this problem? The problem is we cannot do a 2 plus 3 like the computer. We have to make the computer do the 2 plus 3. So somehow we need to convert this 50 into 2, this 51 into 3, and this, so it will produce 2 plus 3 equals 5, and then we convert this 5 into 53, which is equivalent to our 5. How do you do that? Very simple. You see the pattern. To turn 51 into 2, we need to subtract 48. To turn 51 into 3, we also need to subtract 48. Again, if we want to turn 5 into 53, we have to add 48. So this number 48 is very important. It's also the ASCII value of 0. Okay, what we're gonna do is we're gonna subtract, as discussed, here and 48. All 38 in hexadecimal, not people prefer hexa for some reason. And we're gonna do the same thing here, subtract AL and 38 and 48 are the same thing. See, it's in hexa, that's in decimal. And we're gonna add with 38. This should give us, so what I did was this, and this should do this. This is where we do this, and this is where we did this. Now this should run accordingly. Let's see. 2, 1, 3, and voila, it gives us 5. Would you look at that? So this is how it does. And there is one more thing. You see, I have some problem with these two lines. And these two lines, we did some similar common, so we did something along the lines with, like, what we did here was 2 plus 3, and in here what we did is 2 plus 3 minus 38, right? Sorry, plus 38, right? But there's something in here. It's actually 51 minus 38, and in here it's actually 50 minus 38. So all of this translates to, we can say, 50 minus 38 plus 51 minus 38 plus 38. We can see that in this line, right? This 38 and this 38 and this 38 cancels each other, do they not? And this 2 represents 2. The answer is still the same. What it means is, we don't have to do 38 and 38 we don't need to subtract 38 from these two numbers. We can just remove 38 from one number, and we don't need to add this, because it cancels each other out. So if we're gonna do this, it still gives us the same result. So what we're gonna do is we can remove some codes here. Oh, come on, I hate assembly, trust me, it's so painful. We're gonna remove some codes, and it should give us the same results. See, it gives us the same results. So this is how you do add two numbers and get the desired output. Peace.